What if I told you that just beneath our feet lies the potential for unprecedented destruction? Every year, thousands of volcanoes around the globe remind us of their presence, yet only a few possess the power to drastically reshape our civilization. This is the world of supervolcanoes, mighty geological giants that can unleash catastrophic eruptions large enough to blanket continents and plunge the Earth into darkness. Volcanoes have existed for millions of years, and their restless nature has a profound influence on the Earth's climate and geography. The driving force behind these eruptions is magma, molten rock that lies in wait beneath the surface, created from the melting of the Earth's mantle. The pressure from accumulated magma can eventually lead to a violent explosion, spewing ash, gas, and lava into the atmosphere. But not all volcanoes are created equal. Supervolcanoes, like Yellowstone in the United States and Toba in Indonesia, are capable of producing eruptions that can alter the very fabric of life on Earth. Historical records and geological studies reveal that these eruptions have occurred in the past, and the consequences were often dire. For example, the eruption of Mount Tambora in 1815, while not a supervolcano, demonstrated how a volcano can disrupt climate globally. The ash released caused what came to be known as the Year Without a Summer in 1816, leading to widespread famine in Europe and North America. And this was just a mere fraction of the might of nature's fury. But why are supervolcanoes so much more dangerous? It's largely about scale. A typical volcano might erupt every few decades or hundreds of years, but supervolcanoes can remain dormant for tens of thousands of years before exploding in a cataclysmic event. The last eruption of Yellowstone occurred approximately 640,000 years ago. Scientists believe we are overdue for another major eruption, which has created both fascination and fear within the scientific community and the public at large. In the wake of an eruption, the consequences are far-reaching. Ash clouds can spread over vast areas, suffocating populations, and disrupting air travel for months or even years. The climate can shift abruptly, global temperatures could drop significantly, leading to a phenomenon called volcanic winter. According to studies, temperatures could decrease by as much as 10 degrees Celsius for several years. This would severely impact agriculture, leading to food shortages and economic collapse. So, as we delve deeper into the mysteries of these geological titans, we must ask ourselves, how prepared are we for a potential eruption of a supervolcano? What would happen if one of these volcanic behemoths decided to awaken? The stakes have never been higher, and understanding these threats is crucial for our survival. Let us embark on this journey through the heats of the Earth and explore what could happen next. Nestled in the heart of the United States, Yellowstone National Park is a breathtaking landscape known for its stunning geysers and hot springs. However, lurking underneath this national treasure lies one of the most dangerous supervolcanoes on the planet. With its last major eruption occurring approximately 640,000 years ago, the potential for devastation is not merely speculation, it's a reality that scientists are ever more concerned about. Yellowstone sits atop a massive magma chamber that stretches for miles beneath the surface. It's estimated that this chamber contains about 15 times the amount of magma that was expelled during the eruption of Mount St. Helens in 1980. The sheer volume of magma and its pressure buildup over time means that, when the volcano erupts, it can be catastrophic on an unimaginable scale. Researchers have been monitoring geothermal activity in the region for decades. The United States Geological Survey, or USGS, keeps a close eye on seismic activity, ground deformation, and gas emissions, all of which can indicate an impending eruption. Over the past few years, scientists have observed increased earthquake activity around the park, which offers a glimpse into the volcano's ever-shifting state. In 2018, a swarm of over 500 small earthquakes were recorded in a single week, prompting further studies into the volcano's current status. These events are not a cause for immediate panic, but they do underscore the importance of ongoing monitoring. As scientists gather data, they look to understand how the magma chamber is behaving. Are there signs of movement, pressure increase, or gas releases? Each clue adds to a broader puzzle that could reveal the volcano's next move. If Yellowstone were to erupt today, the consequences could be globally catastrophic. Volcanic ash would be propelled miles into the air, blocking sunlight and leading to dramatic drops in temperatures. Estimates suggest that up to 90% of the United States could be covered in ash several feet deep. Imagine New York, Los Angeles, and Chicago buried under tons of ash, effectively paralyzing these cities and disrupting daily life for millions. The United Nations projects that the immediate aftermath of such an eruption could lead to millions of deaths, primarily from asphyxiation and collapsed infrastructure. This scenario becomes even bleaker when we consider the agriculture sector. Crops would fail, livestock would perish, and food shortages would inevitably follow. But what about the rest of the world? The repercussions would not be confined to the United States alone. The ash and gases emitted could cause a volcanic winter, drastically affecting global temperatures. Such an event has occurred in the past, with the eruption of Toba in Indonesia approximately 74,000 years ago, believed to have caused a volcanic winter that may have pushed humanity to the brink of extinction. It's a stark reminder of how interconnected our planet is, and how a single explosive event can send shockwaves far beyond its epicenter. The story of Yellowstone is not just one of danger, but also of resilience and preparedness. The park authorities and scientists are working hard to develop emergency response plans and public education campaigns. While no one can predict when an eruption might happen, being informed about the risks can better equip us to face such an eventuality. As we turn our attention to other supervolcanoes around the globe, the lessons from Yellowstone will certainly be invaluable. Each of these geological giants carries its own story of destruction and survival. What might we discover next? To understand the true power of supervolcanoes, one must look back to Mount Toba, a colossal volcano located on the Indonesian island of Sumatra. Approximately 74,000 years ago, Toba unleashed one of the largest volcanic eruptions in Earth's history, an event that would drastically alter life on our planet. This eruption is not just a geological curiosity, it offers insights into the potential future of supervolcanoes. The Toba eruption expelled an estimated 2,800 cubic kilometers of ash and rock, creating a caldera that is about 100 kilometers wide. But its immediate impact rippled far beyond the island of Sumatra. The ash cloud released into the atmosphere was so dense that it is believed to have caused a volcanic winter lasting several years, with global temperatures dropping by around 10 degrees Celsius. This drastic change in climate led to widespread famine, which may have severely impacted human populations at the time. Research suggests that the human population may have dwindled to as few as 15,000 individuals following the Toba eruption, which some scientists speculate contributed to a genetic bottleneck in modern humans. Many of us today carry the DNA of those resilient survivors. Not only does Toba serve as a reminder of the past, but it also holds valuable lessons for our future. The supervolcano remains active today, with scientists monitoring the caldera closely for signs of unrest. Geologically, Toba is a classic example of how supervolcanoes can remain dormant for millennia, only to awaken with little warning. Toba's eruptions have been linked to various climate change events, and researchers are utilizing advanced modeling technologies to study the potential impact of another eruption. Through simulations, scientists can predict how ash dispersal would affect agriculture, ecosystems, and human populations across the globe. In light of Toba and its historical significance, one must consider the frequency of supervolcanic eruptions throughout geological history. On average, it has occurred about once every 50,000 years. Since we are now 74,000 years removed from the last one, the question looms, are we past due? Toba teaches us that nature's fury can be more powerful than we can fathom, and the implications for human civilization could be disastrous if we are unprepared. However, the studies being conducted today could offer critical insights into our future. Could we, equipped with advanced technology, mitigate the potential effects of a supervolcano? As we reflect on this, we must wonder how many stories from the past remain to teach us about our present and future. As we turn our gaze to Europe, another formidable contender emerges from the shadows of history, Campi Flegrei, located near Naples, Italy. Often referred to as the Phlegrean Fields, this supervolcano has a history of eruptions that have altered the landscape and impacted human civilization for thousands of years. With its last major eruption occurring over 39,000 years ago, Campi Flegrei could awaken at any moment, and the implications would be dire. The supervolcano consists of multiple craters formed from a series of eruptions, including the massive eruption known as the Campanian ignimbrite. This event is said to have produced ash deposits that spread across much of Europe, affecting early human populations and making the region inhospitable for centuries. The ash fallout and the resulting climate changes would have significantly impacted local agriculture and led to mass migrations. Modern studies indicate that Campi Flegrei is still an active and dangerous entity. In recent years, scientists have noted increased ground deformation, gas emissions, and seismic activity in the area, which has raised alarms among geologists. Researchers have begun to investigate potential eruption scenarios that could emerge from this sleeping giant, acknowledging that the consequences could be catastrophic not just for Italy, but for the entire Mediterranean region. The Italian government has initiated monitoring programs to ensure public safety, and scientists are continuously assessing the risks associated with a potential eruption. Just like Yellowstone and Toba, Campi Flegrei holds a terrifying secret within its depths, one that could affect millions of lives. If Campi Flegrei were to erupt today, the ramifications could echo throughout Europe. The ash cloud could disrupt air travel, leading to economic chaos, while lower temperatures would impact growing seasons across the continent. Moreover, Naples, a city filled with rich history and culture, could find itself buried beneath several feet of ash, leading to loss of life and heritage. The idea that a volcanic event could lead to mass migration and social unrest is not far-fetched. During the last considerable eruption of Campi Flegrei, populations fled the region, leaving behind their homes and livelihoods. Modern cities are not immune to such chaos. Within a single generation, millions could find themselves displaced as climate patterns shift and economies collapse due to an eruption. In light of this, researchers are advocating for better preparedness, focusing on community education and emergency response plans. The goal is to ensure that in the face of nature's fury, human civilization can respond adequately and preserve what we can. As we continue to explore other supervolcanoes, we must reflect on the lessons held within the depths of Campi Flegrei. Can we truly prepare for such an incomprehensible event? History teaches us that humanity is resilient, yet it also shows us that we are vulnerable to the whims of nature. As we discuss the potential catastrophes posed by supervolcanoes, it is essential to recognize how past events have shaped human society and our understanding of resilience. Cities have been built, destroyed, and rebuilt, often learning from the lessons of disaster. The eruption of Mount Vesuvius in 79 AD is a poignant example. The destruction of Pompeii and Herculaneum serves as both a warning and a reminder of nature's incredible power. However, it also teaches us about the importance of preparedness and the ability to adapt. After the volcano's eruption, new building codes, urban planning, and even cultural practices emerged to mitigate the impact of future disasters. The legacy of these events extends to modernity. As we assess cities vulnerable to natural disasters today, a fundamental question arises: are we better prepared? The advancements in technology, geological research, and emergency management have come a long way, but challenges remain. Countries located near supervolcanoes are now employing high-tech monitoring systems, conducting emergency drills, and developing public education campaigns aimed at preparing populations for potential eruptions. Communication of risk is essential in these preparations, laying out clear action plans and ensuring everyone knows the proper steps to take in case of an emergency. In addition to government efforts, grassroots organizations are stepping up to raise awareness and engage communities in disaster preparedness. Social media and online platforms have become vital tools for educating the public about the threats posed by supervolcanoes. But education alone cannot guarantee resilience. We must also incorporate scientific discoveries into urban planning and infrastructure design. Resilient cities are those that anticipate potential disasters and build accordingly. For instance, structures can be designed to withstand heavy ash fallout and evacuations can be planned for large populations. Investing in sound science and technology for risk mitigation can save countless lives. As we move forward, it's crucial for global cooperation to address these threats. Climate change, urbanization, and population growth compound the risks that supervolcanoes pose to our civilization. By fostering collaboration amongst countries, we can share knowledge, resources, and strategies to prepare for potential eruptions. The collective memories of past disasters should inspire us to act. Humanity has always faced challenges and has risen to meet them through ingenuity and determination. As we conclude this exploration of supervolcanoes, let's remember, while we may face an uncertain future, the resilience of humanity can shape that future positively. Will we take these lessons to heart and prepare, or will we leave ourselves vulnerable to the might of nature? Volcanic ash. It sounds harmless, even inconsequential, doesn't it? But the truth is far more alarming. When a large volcano erupts, it spews massive amounts of ash into the atmosphere, and this ash can cover entire regions, disrupt air travel, and affect global climate. Imagine a scenario where a supervolcanic eruption blankets the skies. Ash clouds can remain suspended for years, blocking sunlight and cooling the Earth's surface. Historical records tell us that the eruption of Mount Pinatubo in 1991 released enough ash and sulfur dioxide to lower global temperatures by an average of 0.5 degrees Celsius for 2 years. Now, consider the potential of a larger eruption, one like the Yellowstone supervolcano. Such an event could unleash ash clouds thousands of miles wide, affecting vital agricultural regions in the Americas, Europe, and beyond. Studies indicate that a significant eruption could lead to a drastic reduction in agricultural output. When Mount Tambora erupted in 1815, it caused what became known as the year without a summer. Crop failures, food shortages, and social unrest followed. The ash from that eruption circled the globe, contributing to extreme weather patterns. But it isn't just the immediate fallout we have to worry about. The long-term effects of volcanic ash on the environment can be catastrophic. Volcanic ash can contaminate water supplies, destroy infrastructure, and lead to respiratory problems for those who inhale it. In Iceland, the 2010 eruption of Eyjafjallajökull disrupted travel across Europe but also released substantial ash, prompting both natural and human-made systems to adapt. In regions close to the eruption, the impacts are even more pronounced. Entire communities can lose their livelihoods, leading to economic devastation that can take years to recover from. If a supervolcano erupted today, the societal effects could cascade rapidly, food shortages could lead to panic, economic instability could result in civil unrest, and the health consequences could overwhelm local healthcare systems. As we look forward, scientists are studying modern early warning systems to help mitigate these disasters. Monitoring volcanic activity in real time could be the key to saving lives and protecting economies. Yet, even with technology on our side, the sheer scale of destruction a supervolcano could unleash continues to be a stark reminder of nature's unpredictable fury. As we venture deeper into the implications of such eruptions, we must consider the socio-political ramifications. How would governments react? Would global cooperation ensue, or would nations turn against one another in the face of disaster? As volcanic ash settles, another question lingers in the background, compelling us to confront the delicate balance of our existence with nature's untamed forces. Volcanism has long been intertwined with the Earth's climate system. When we think of climate change, we often focus on human activity, deforestation, fossil fuel combustion, and industrial processes. Yet, natural events like volcanic eruptions play an equally crucial role. Volcanic eruptions can inject massive amounts of carbon dioxide and sulfur dioxide into the atmosphere, influencing climate patterns for years. For instance, the eruption of Mount St. Helens in 1980 released about 1 million tons of sulfur dioxide into the atmosphere. This gas formed sulfate aerosols, which reflect sunlight, leading to a cooling effect, a temporary reprieve in a warming world. Yet, this is a double-edged sword. While a reduction in temperature might seem beneficial, it can also disrupt weather patterns, leading to extreme events. Consider the early 1900s when the eruption of Krakatoa in 1883 caused global temperatures to drop significantly. The climate change that followed was unprecedented at the time, creating a series of unusual weather anomalies around the globe. The societal implications were severe. Failed harvests, famine, and social upheaval were just some of the challenges that arose in the years following the eruption. This connection between volcanism and climate raises questions about the future. How might a massive volcanic eruption exacerbate our current climate crisis, which is already pushing natural systems to the brink? Scientists are probing this question with increasing urgency. Recent studies indicate that large-scale volcanic eruptions could lead to feedback loops in climate systems that might push us beyond tipping points. As we continue to track and study these processes, we must also consider the human dimensions. How resilient are we to such natural shocks? Can we mitigate the impacts of climate change while preparing for the effects of volcanic activity? The intersection of volcanism and climate change is a complex web of interaction. The more we learn, the more we realize that our future may be largely shaped by events beyond our control. Will we be prepared, or will we find ourselves once again at the mercy of nature's volatile temper? As we delve deeper into this conundrum, it's essential to remember that every action has a reaction. The question looms, are we equipped to handle the repercussions? The Laki eruption in 1783 stands as a powerful testament to the potential devastation of volcanic activity. Located in Iceland, Laki erupted for 8 months, spewing forth a staggering 14 billion tons of lava and gases into the atmosphere. The immediate impact was catastrophic for the island's population, with approximately 25% of Icelanders perishing due to famine and disease brought on by the eruption's toxic gases. But the story doesn't end there. The gases released during the eruption, particularly sulfur dioxide, had far-reaching consequences beyond Iceland's shores. The eruption led to the formation of aerosol clouds that spread across Europe, causing severe weather anomalies. Historical records note an extraordinarily harsh winter in 1784. Food shortages and mortality rates spiked across Europe as crops failed. This volcanic event serves as an example of how interconnected our world truly is. In England, for example, farmers faced catastrophic crop failures, leading to skyrocketing grain prices and civil unrest. The connection between Laki's eruption and the subsequent societal upheaval exemplifies how a volcanic event can ripple through economies and communities, far removed from the epicenter of the eruption. The Laki eruption also had implications for science and understanding volcanism. It prompted many to examine the relationship between volcanic activity and climate, learning lessons that would shape future volcanic studies. As we reflect on Laki today, it raises an uncomfortable question. if a similar event were to occur now, would we be prepared? Given the globalization of trade and interconnectedness of modern societies, how rapidly could we respond to such a catastrophe? Volcanic events like the Laki eruption remind us of our vulnerability. Scientists today are using data and technology to understand past eruptions better and prepare for future threats. Are we capable of learning from history? The lessons of Laki may hold the key to our resilience in the face of nature's fury, and as we uncover more stories from the past, the question remains, how will we adapt to the volcanic threats of the future? Preparation is not just about having the right tools, it's about understanding the landscape of risk we live in. As we've seen throughout history, the devastating impacts of volcanic eruptions can surprise even the most prepared. With advancements in science and technology, we are better equipped than ever to predict volcanic activity. Geologists and volcanologists across the world are now utilizing satellite imagery, seismic monitoring, and gas emissions analysis to track volcanic activity in real time. Early warning systems are being implemented in high-risk areas, aiming to provide critical data that can save lives. The 2010 eruption of Eyjafjallajökull is a prime example of this new defensive stance. Despite significant disruptions to air travel, the advance warning allowed for coordination and evacuation, saving countless lives. However, challenges remain. The unpredictability of volcanic eruptions poses a significant hurdle. Scientists are still grappling with how to provide accurate predictions for populations living in the shadow of supervolcanoes. For instance, the Yellowstone area is constantly monitored, yet predicting the exact timing and magnitude of imminent eruptions remains elusive. How can communities prepare for events that could occur with little warning? Public education plays a vital role in preparedness. Local governments must engage with communities, ensuring they understand the risks and have evacuation plans in place. Countries around the Pacific Ring of Fire, including Japan and Indonesia, have developed comprehensive disaster response strategies that can serve as models for other nations. These strategies include not just evacuation plans but also community drills and educational campaigns around volcanic hazards. Furthermore, international cooperation and information sharing can bolster our collective preparedness. By uniting global scientific efforts and sharing best practices, we can create a network of vigilance that can respond to volcanic threats effectively. The question remains, in our globalized society, will we work together to face these challenges? The risk of volcanic eruptions is a reminder of the forces we cannot control. While we prepare, we must also cultivate resilience within our communities. How can we create cultures that are adaptable, able to face the multifaceted challenges posed by natural disasters? As we ponder this, it's essential to remember that the best defense against nature's might is knowledge, collaboration, and preparedness. As we look to the future of volcanology, we stand at the crossroads of opportunity and necessity. The advances in technology and understanding of volcanic processes offer a beacon of hope in our quest to live harmoniously with these powerful natural phenomena. Scientists are leveraging machine learning and big data analytics to enhance eruption forecasting capabilities. The integration of diverse datasets, from satellite imagery to social media reports, provides a nuanced picture of volcanic behavior, increasing the accuracy of predictions. Moreover, interdisciplinary collaborations are becoming essential. Climate scientists, geologists, and urban planners are joining forces to create comprehensive volcanic risk management strategies. For instance, in regions prone to volcanic eruptions, urban development must be guided by geological expertise to prevent disasters before they happen. This proactive approach holds the promise of sustainable living in volcanic regions, balancing human needs with the realities of living in nature's dynamic environment. But as technology advances, ethical questions arise. How much should we manipulate natural processes when it comes to hazard mitigation? Some propose geoengineering techniques to counteract the effects of eruptions, yet the repercussions of such actions are largely unknown. Our understanding of ecological systems is still developing, and the moral implications must be weighed carefully. Looking ahead, public engagement will be crucial. The general populace must be educated, not only on the science behind volcanology but also on the decisions being made about their environments. The success of any preparedness strategy hinges on community involvement, ensuring that local voices are heard and respected in the conversation about risk and safety. As we envision the future, we must keep in mind the ethical balance that governs our relationship with nature. The ultimate question we need to ask ourselves is, how do we coexist with the Earth's volatile mechanisms while nurturing resilience and preparedness within our communities? In summary, the story of volcanoes is not just one of destruction but of rebirth and resilience. It is a tale that invites us to understand the Earth more deeply, equipping us to face its challenges head-on. As we conclude this exploration of volcanoes that could end civilization, we are left not just with the fear of possible cataclysms but with the hope that through knowledge and collaboration, we can navigate the complexities of our world. The journey continues, and the future is shaped by the choices we make today. Throughout history, volcanoes have captured the imagination of civilizations. The sight of molten lava flowing down their slopes, the rumble of earth shaking, and the ominous clouds of ash have inspired countless myths and legends. From the ancient Romans who believed that the god Vulcan forged weapons in Mount Etna, to the Pacific Islanders who feared Pele, the goddess of fire and volcanoes, the relationship between humans and these fiery mountains has always been complex. The legends serve not only as cautionary tales but as mirrors reflecting the societies that created them. For example, the Hawaiian goddess Pele is central to many stories, embodying the dual nature of creation and destruction. Her eruptions are seen not just as devastating events, but as a necessary force for the land's renewal. In the early 2000s, when Kilauea erupted, it was an event that sparked both fear and celebration among local residents. They understood eruptions as an integral part of their environment, framing the eruption in the context of Pele's influence. Such beliefs helped these communities cope with the devastation that followed. Moreover, volcanoes have found their places in literature and art. Dante Alighieri's Inferno features a vision of Mount Etna, symbolizing the torment of the damned. In this way, volcanoes not only impact the physical landscape but have significant cultural repercussions, shaping the narratives of those who coexist with them. The stories we tell about volcanoes can warn us, educate us, and connect us across generations. But as we explore these myths, are we also downplaying the very real threats these giants pose? What happens when the legends clash with scientific reality? Let's dive deeper into the dualities of fire and earth, exploring how these magnificent forces have shaped our cultures and our fears. The next section will highlight some of the most famous volcanic myths across different cultures, examining how they reveal humanity's ongoing relationship with nature's fury. Volcanoes are notoriously unpredictable. Geologists and volcanologists have made significant strides in understanding the signs of impending eruptions, yet the challenge remains formidable. In this chapter, we will explore the science behind volcanic prediction, examining the technologies and methodologies employed in the field. One of the most relied upon tools is the monitoring of seismic activity. Earthquakes often precede eruptions as magma forces its way through the crust, causing tremors. For instance, the 1980 eruption of Mount St. Helens followed a series of earthquakes that signaled the impending explosion. Scientists were able to detect a significant increase in seismic activity weeks prior, allowing for some evacuation of nearby residents. However, not all volcanoes provide such clear warnings. In some cases, eruptions occur with little to no seismic precursor, as seen in the case of the 1991 eruption of Mount Pinatubo in the Philippines. Technological advancements like satellite remote sensing are also essential. These systems can detect ground deformation and thermal anomalies that indicate magma movement beneath the surface. For example, the Global Positioning System, GPS, is used to monitor ground movements around volcanoes like Kilauea. In 2008, changes in the GPS readings were crucial in predicting the eruption that would occur shortly after. In addition to technology, scientific collaboration plays a vital role in volcanic prediction. Global networks of scientists share data and insights to improve monitoring systems, informed by case studies from around the world. Yet, despite these advancements, challenges remain. How do we communicate uncertainties in predictions to the public? The danger lies not only in the eruption itself but in the panic and chaos that inevitable uncertainties can cause. As we delve deeper into the science of prediction, the question stands: can we ever truly outsmart nature? Volcanic eruptions leave legacies that last for generations. In this chapter, we will discuss the long-term impacts of volcanic disasters on communities and their environment. The immediate aftermath of an eruption can be catastrophic. The 1985 Nevado del Ruiz eruption in Colombia tragically exemplifies this, where a volcanic mudflow swept through the town of Armero, claiming the lives of over 23,000 people in a matter of minutes. Recovery from such devastating events is a long and arduous journey. Communities must deal with not only the physical destruction but also emotional trauma. The psychological impacts can linger for years, affecting mental health and community cohesion. In the years following the eruption, many survivors report feelings of loss and anxiety, conditions that can often escalate into further societal issues, such as increased crime and domestic violence. Additionally, the environment faces immense pressure. Ash covers landscapes, altering ecosystems and affecting agriculture. An example can be seen in the aftermath of the 1991 Mount Pinatubo eruption, which altered local weather patterns, leading to significant crop failures in the years that followed. Even as recovery efforts begin, the geological landscape remains altered. Volcano monitoring becomes increasingly important to forewarn communities of the new realities they inhabit. Organizations must balance immediate humanitarian needs with long-term recovery plans, often leading to difficult political and economic decisions. But beyond recovery, there's also resilience. Communities often rebuild stronger and more cohesive than before, learning to live with the risk that their environment poses. As we conclude this chapter, let's reflect on how these communities embody the spirit of resilience in the face of adversity. Their stories remind us that even in the shadow of destruction, hope can rise anew. What does it take to rebuild, not just physically, but emotionally and spiritually? In an age where technology connects us like never before, the world is continuously monitoring the power of volcanoes. The Global Volcanism Program, operated by the Smithsonian Institution, diligently tracks volcanic activity worldwide. With over 1,500 active volcanoes, scientists rely on a network of volcano observatories and satellite data to predict eruptions. This interconnected system not only records activity but also disseminates crucial information to local populations. For instance, in 2010, when the Age of Geological volcano erupted in Iceland, the swift reporting and analysis allowed governments to prepare for the ensuing flight disruptions that brought European air traffic to a standstill. It demonstrated the vital role of global collaboration in addressing volcanic threats. But can our technological advancements truly protect us from the catastrophic consequences of a major eruption? In this chapter, we delve into the tools and techniques used by scientists to monitor volcanoes and assess their potential threat levels. From remote sensing technology to on-the-ground surveys, the methods of understanding these geological giants are constantly evolving. Moreover, countries with dangerous volcanoes, like Italy and Indonesia, have established systems for real-time monitoring, improving response times and saving lives. The role of citizen science has also emerged, where locals contribute observations, knowledge honed over generations, strengthening the data pool available to researchers. However, reliance on technology does not mean we can become complacent. The unpredictability of volcanoes makes them both fascinating and terrifying. Scientists are now grappling with the challenge of integrating historical data with real-time monitoring to enhance predictive models. As we explore the multifaceted world of volcanic monitoring, one question looms: are we truly prepared for the next big eruption? Let us uncover the layers of technology and human ingenuity aimed at deciphering the violent heartbeat of the Earth below. Imagine living under the constant shadow of a volcano, where the ground beneath your feet is a reminder of nature's destructive power. As civilization advances, our relationship with volcanoes must evolve. The question arises: how do we coexist with these formidable forces of nature? This chapter delves into the innovative strategies that communities are adopting to prepare for and mitigate volcanic dangers. In places like Naples, at the foot of Mount Vesuvius, urban planning incorporates volcanic risk assessments to create safer living environments. Here, engineers employ advanced construction methods that can withstand seismic activities and ash fall. Moreover, educational programs play a crucial role in ensuring that residents are aware of potential evacuation routes and safety protocols. An example of effective community engagement is seen in the Philippines, where families living near Mount Mayon participate in drills and preparation activities. This proactive approach aims not only to safeguard lives but also to instill resilience against the inevitable volcanic threats. But what happens to societies that lack such preparedness? The 1991 eruption of Mount Pinatubo serves as a stark reminder. Nearly 1.2 million people were displaced, demonstrating the dire consequences of inadequate planning. Recovery from such events can take decades, with long-term economic impacts. In contrast, the island of Hawaii has adopted a unique approach, embracing the presence of Kilauea and its eruptions as part of their identity and economy. Tourism flourishes, drawing visitors to witness the awe-inspiring lava flows. This relationship with the volcano has transformed a threat into an opportunity, highlighting the duality of living with such geological giants. As we explore these strategies, one question arises: can humanity learn to live harmoniously with the wrath of volcanoes, or are we forever at their mercy? As we contemplate the future of living alongside volcanoes, the narrative shifts towards the balance of risk, preparation, and resilience, challenging us to rethink our place in this geologically active world. While the physical destruction caused by volcanic eruptions is often documented in stark statistics, the psychological ramifications are equally profound yet less frequently discussed. Living in the shadow of a volcano can create a constant state of anxiety. Research indicates that communities near active volcanoes experience heightened stress levels, which can lead to mental health crises during eruptions. This chapter delves into the unseen scars left by volcanic activity, stories of individuals and families who have endured the trauma of displacement and loss. Consider the residents of the Lacher See area in Germany. After a catastrophic eruption occurred about 12,900 years ago, the psychological imprint remained. The fear of a potential repeat event looms large, affecting local heritage and mental wellness. In contrast, the 1980 eruption of Mount St. Helens offers a modern case study. Survivors reported experiencing post-traumatic stress disorder, anxiety, and grief after their lives were irrevocably changed. Moreover, the process of rebuilding emotionally can take as long, if not longer, than the physical reconstruction. Experts emphasize the need for mental health resources in areas prone to volcanic activity, yet these services often lag behind. The role of community support and resilience strategies are crucial in helping individuals cope. Engaging communities in recovery programs and fostering a sense of belonging can mitigate the psychological toll. As we uncover these stories and statistics, we begin to realize that the disaster of a volcanic eruption extends far beyond its physical devastation. It permeates the very fabric of those who bear witness. As the chapter comes to a close, let us reflect on a difficult truth. Nature's fury does not just claim lives, it leaves behind a legacy of emotional scars that can last for generations. How can societies learn to heal and support each other in the aftermath, ensuring the psychological well-being of those living in the volcanic zone? As we venture deeper into the wondrous world of volcanoes, many of us often overlook the hidden giants lying beneath thick sheets of ice. Subglacial volcanoes, dormant and formidable, are hidden beneath glaciers, waiting for the right conditions to unleash their potential. These volcanoes can be sparked to life by the Earth's heat, causing catastrophic eruptions that can escalate far beyond simply melting ice. Take, for instance, the subglacial volcano beneath Iceland's Vatnajökull Glacier. Here, the intersection of ice and molten rock creates a ticking time bomb. If it were to erupt, the results could be disastrous: massive flooding, ash clouds, and a sudden shift in climate. This is not just an academic concern. In 1996, an eruption occurred beneath the same glacier, resulting in a meltwater flood that devastated nearby towns, washing away roads and infrastructure in mere hours. We must understand these hidden threats, for they are not entirely dormant, they are just waiting, silently plotting their potential devastation. Globally, there are over 200 known subglacial volcanoes, and many are located in hotspots such as Antarctica and Greenland. How many of these volcanoes are just biding their time, prepared to release their fury? Experts are now reinforcing the need for advanced surveillance and innovative technologies to monitor these concealed volcanoes. Without understanding what lies beneath, we risk being blind to the next major eruption on the horizon, an explosion that could alter not just the landscape, but humanity itself. The tangled web of ice and fire reminds us of nature's raw power and its relentless capacity to challenge humanity's existence. It begs the question, what are we doing to uncover these mysteries, and how prepared are we for their consequential wrath? Let's explore what we know about these enigmatic creatures of the earth and how we can equip ourselves against their unpredicted fury. Every volcanic eruption tells a story that transcends borders and impacts civilization as a whole. They don't just shake the ground beneath our feet, they change weather patterns, displace communities, and alter ecosystems. A classic example of this is the 1815 eruption of Mount Tambora in Indonesia. This cataclysmic event, considered one of the most powerful eruptions in recorded history, spewed out an estimated 100 cubic kilometers of ash into the stratosphere. The fallout created what became known as the Year Without a Summer in 1816, leading to widespread crop failures and food shortages throughout parts of North America and Europe. It is suspected this eruption resulted in the deaths of around 90,000 people, showcasing how interconnected our world has always been, even in the face of natural disasters. The ash cloud affected global weather systems, resulting in a dramatic temperature drop that caused agricultural collapse. This is a stark reminder of the repercussions volcanic activity can have on global food supplies and economic stability. Fast forward to 2010, when the eruption of Eyjafjallajökull disrupted air travel across Europe for months. Over 100,000 flights were cancelled, stranding millions of passengers and costing billions in lost revenue. This eruption showcased just how quickly a single volcanic event can disrupt our technologically advanced society. The speed of modern life is often predicated by our reliance on air travel, and volcanoes challenge this convenience with their unpredictable natures. The psychological and emotional impacts of volcanic eruptions must also be recognized. Communities devastated by ash fall have to grapple with loss and resilience, rebuilding their lives after nature's fury strikes. It takes years, sometimes generations, to recover from the psychological toll of such devastation. The global impact of volcanic eruptions cannot be understated. they create ripples that affect economics, politics, and mental health across continents. As climate change continues to evolve, it's critical to monitor these explosive beasts with more precision than ever before. What lessons can we learn from these past eruptions, and how can they inform our future actions to mitigate their catastrophic impacts? Let's take a closer look at how societies adapt and prepare for the uncertain future, where the next explosion is just waiting to remind us of nature's dominance. Through history, humanity has faced numerous challenges posed by volcanic eruptions. Yet, what is remarkable is how these challenges have also spurred innovation and resilience. Take the ancient Minoans, who thrived on the island of Santorini until the eruption of Thera around 1600 BC. While the eruption led to significant destruction, it also laid the foundation for advancements in architecture and urban planning as survivors adapted to the new landscape. The remnants of these innovations can still be observed today. Post-eruption, civilizations often become more adept at creating structures that can withstand natural disasters, leading to improved building codes and practices. In modern times, the 1980 eruption of Mount St. Helens prompted a wave of research and advancements in geology, volcanology, and emergency management. The eruption served as a wake-up call, leading to the establishment of the United States Geological Survey's Volcano Hazards Program. This initiative has become instrumental in monitoring volcanic activity, enhancing our ability to forecast eruptions and mitigate their impacts. The importance of this cannot be overstated. Communities that once faced destruction are now equipped with real-time data and advanced warning systems. Advancements in drone technology now allow us to survey volcanic terrains that were previously unsafe to explore on foot. Drones can monitor gas emissions and lava flows, providing invaluable data rapidly and efficiently. Innovative techniques like these remind us that while volcanoes pose incredible risks, they also compel us to adapt, evolve, and foster resilience. As we gaze into the future, we must ask ourselves, how will we continue to embrace the scientific inquiry and technological advancements born from our encounters with these mighty forces of nature? What further heights can we achieve when faced with the challenges volcanoes present, and how might our evolving relationship with these natural wonders shape the world ahead? Throughout history, volcanic eruptions have played a pivotal role in shaping civilizations. The eruption of Mount Vesuvius in AD 79 is one of the most infamous examples. With a force equivalent to 100,000 times the atomic bomb dropped on Hiroshima, Vesuvius buried the Roman cities of Pompeii and Herculaneum under a thick blanket of ash and pumice. This catastrophic event preserved a snapshot of Roman life, frozen in time. Archaeologists have meticulously excavated these sites, offering insight into the daily lives of ancient Romans, their architecture, and even their food. But the influence of volcanoes on civilization extends beyond destruction. For instance, the fertile lands created by volcanic soil have allowed agriculture to thrive. The regions surrounding Mount Etna in Sicily have produced some of the best wines and agricultural products in Europe for centuries. This volcanic soil, rich in essential nutrients, has been a double-edged sword, providing sustenance while also posing a threat of eruption. The duality of volcanoes as both creators and destroyers is a recurring theme in our planet's history. We can also look at the ancient Minoans on the island of Santorini, where the catastrophic eruption around 1600 BC led to the collapse of one of the most advanced societies of its time. This eruption created the caldera that we see today, transforming the landscape and disrupting trade routes across the Aegean Sea. The ash and gases released over several days would have caused climate disruptions, altering weather patterns and potentially leading to famine. The Minoans never fully recovered, and their societal collapse links to the broader effects of volcanic eruptions. Moreover, the famous eruption of Krakatoa in 1883 not only caused massive destruction but also had lasting effects on climate and weather. This eruption created a global climate anomaly, with temperatures dropping significantly due to the vast amounts of sulfur dioxide released into the atmosphere. The darkened skies affected agriculture worldwide, showcasing how interconnected our climate systems are with volcanic activity. Throughout history, these eruptions have taught us about resilience, adaptation, and the fragility of human civilization when faced with nature's might. The power of volcanoes can ignite conflict, reshape borders, alter societies, and even change the course of history itself, reiterating the profound influence of these geological giants on humanity. As we delve deeper into our exploration of volcanoes, one must ask, how do we prepare for such ancient forces when they awaken again? In our next chapter, we dive into the future of volcanology and how scientists are developing new technologies to mitigate the risks presented by these formidable natural phenomena. The relationship between volcanic activity and food security is complex and often paradoxical. On one hand, volcanic soil is among the most fertile in the world, supporting agriculture in numerous regions. On the other hand, volcanic eruptions can obliterate crops, disrupt food supply chains, and lead to famine. The tension between these two aspects of volcanism poses a significant challenge to global food security. One of the most profound illustrations of this can be observed in Indonesia, home to some of the world's most active volcanoes. The volcanic soil across the country has made it a leading producer of rice, coffee, spices, and tropical fruits. However, eruptions pose significant risks. For example, the eruption of Mount Sinabung, which began in 2013, led to the evacuation of thousands of residents and destroyed agricultural land. The immediate effect was clear: local farmers lost their harvests and food prices spiked. This stark reality underlines the vulnerability of food systems in volcanic regions. Research shows that eruptions can lead to food shortages far beyond the immediate vicinity. The 1815 eruption of Mount Tambora, also in Indonesia, had global repercussions, triggering what became known as the Year Without a Summer in 1816. This event led to widespread crop failures in the Northern Hemisphere, resulting in food riots and significant loss of life. Reports from that year detail how snow fell in June in New England, and global temperatures plummeted. This eruption serves as a reminder that the effects of volcanism can be felt across continents, transforming the landscape of agricultural production and food availability. In contrast, volcanic eruptions can also lead to innovative agricultural practices. After the eruption of Mount St. Helens in 1980, which devastated vast tracts of land, the recovery process inspired new methods of soil enrichment and land management. Over time, the ash enriched the surrounding soil, leading to a resurgence of flora and fauna. Farmers learned to harness volcanic ash to improve soil health, demonstrating resilience and adaptation. This phenomenon has prompted a dialogue on sustainable food practices in the face of natural disasters. As we move forward, how do we navigate this intricate relationship between volcanic activity and food security? How can science support farmers in mitigating the risks? In our next chapter, we will explore innovative agricultural techniques that are being researched to withstand the threats posed by volcanoes and improve food resilience for communities worldwide. Volcanic eruptions are not just geological events, they are deeply human experiences that test the resolve and resilience of communities. How people respond to these natural disasters reflects the indomitable spirit of humanity. Whether through evacuation orders, community organizing, or innovative recovery methods, the human response to volcanic threats can be both inspiring and heart-wrenching. Take, for instance, the residents of the island of Montserrat in the Caribbean. Following the eruption of the Soufriere Hills volcano in 1995, the island faced unprecedented challenges. Almost two-thirds of the population was forced to evacuate as volcanic ash and pyroclastic flows devastated towns. Yet, amidst this chaos, the community demonstrated extraordinary resilience. They organized themselves, formed support networks, and worked together to rebuild their lives and their island. Their story is one of courage and determination. Over the years, Montserrat has transformed into a symbol of resilience. Despite the risk of future eruptions still looming, the spirit of the community remains strong. Initiatives to promote tourism and sustainable living have emerged, further showcasing the strength of the human spirit in the face of disaster. How do communities reorganize? How do they redefine their identities in the aftermath of destruction? The eruption of Mount Pinatubo in 1991 provides another lens into human resilience. The volcanic disaster led to one of the largest evacuations in history, affecting thousands of families. The Philippine government worked to establish shelter and provide support for those displaced. In the years that followed, international aid poured in, and communities began rebuilding. Yet Pinatubo's eruption was not merely a story of loss, it also led to significant advancements in volcanic research and emergency preparedness. The establishment of early warning systems and improved communication with local populations became hallmarks of the recovery process, emphasizing the vital role of human ingenuity in the face of nature's fury. These stories remind us that when lava flows and ash clouds diminish, it is the people left behind who must navigate the uncertain path to recovery. How can we empower these communities further? What lessons can we learn from past volcanic disasters to better prepare future generations? In our concluding chapter, we will reflect on the key takeaways from our journey and envision how we can harness scientific understanding to face the volcanic challenges that lie ahead. In the realm of volcanic eruptions, we often focus on the fiery lava, explosive ash clouds, and cascading pyroclastic flows. However, one of the most insidious aspects of volcanic activity lies in the gases emitted by volcanoes. Volcanoes release a variety of gases, including carbon dioxide, sulfur dioxide, and hydrogen sulfide. These gases, while invisible and often odorless, can have devastating impacts on both the environment and human health. Take, for instance, the 1986 Lake Nyos disaster in Cameroon. A sudden release of carbon dioxide from the lake, which had been saturated by volcanic activity, resulted in the suffocation of over 1,700 people living nearby. This cataclysmic event serves as a stark reminder that a volcano's danger is not solely in its eruptions, but also in the gases it can release without warning. In addition to the immediate threat of these gases, the long-term environmental impacts can be profound. Sulfur dioxide, for example, when released into the atmosphere, can react with water vapor to form sulfuric acid, leading to acid rain. This not only damages crops but can also lead to the acidification of lakes and streams, disrupting entire ecosystems. Moreover, volcanic gases contribute to climate change. According to a study published in the journal Nature, significant eruptions can inject large amounts of sulfur dioxide into the stratosphere, forming a reflective veil that cools the Earth's surface temporarily. The eruption of Mount Pinatubo in 1991 is a prime example. It led to a global temperature drop of about 0.5 degrees Celsius for roughly 2 years. So, the next time we think about the power of volcanoes, it's critical to consider not just their fiery eruptions but also the subtle and chilling threats posed by their gases. This hidden danger requires continuous monitoring, as it can lead to ecological disasters and even human casualties without any visible signs of eruption. How can we prepare for such an unseen enemy? Understanding the mechanisms by which these gases are released and how they impact our environment will be pivotal in addressing future volcanic threats. As we move forward, how can we better anticipate and manage these hidden dangers? When we think of tsunamis, our minds may immediately turn to the earthquakes that often trigger these colossal waves. However, volcanic eruptions can also produce tsunamis, creating a deadly combination that few are prepared for. Take the 1883 eruption of Krakatoa as a case study. This eruption not only destroyed the island but also generated massive tsunamis that reached heights of over 40 meters, obliterating coastal towns and resulting in an estimated 36,000 deaths. The mechanism behind such tsunamis typically involves the collapse of a volcanic island or the explosive eruption displacing large volumes of water.